Students, this is the take-home practice quiz. We're going to be doing about half of this together. 1 and 2, that is graphing of lines. I am not going to help you with that. That's something you should be very comfortable with right now. So work through 1 and 2 on your own. Okay, so taking a look at number 3, we have a distributive with radicals. So the first and most important thing here is for you to actually draw the distributive lines. So put a line here, go this way, line back here, and we're distributing to both. Now you write out your distribution. That's going to be 5 root 15 times, technically there's a -1 there, -1 root 5, that's the black, plus 5 root 15 again, times 2 root 3. Okay, now we multiply outies to outies, innies to innies. So we do 5 times -1, which is, what guys? Participate. Yeah. All right, and then we're going to do 15 times 5. All right, bring down the plus sign. You do outies and innies again. Outies, multiply. Innies. From here, you factor both of these. You factor and you simplify. Alrighty, so 3, you needed to simplify, and as you simplify things, you pull it out and you multiply by the outside. Take right now. And we're taking a look at number 5 now. Now the trick to 5 is the fact there's a radical in the denominator. You can't have radicals in the denominator. That's a no-no. So the first thing we're going to do, I'm going to draw it nice and big. So draw it big as well. So we have 2 root 6 and 3 root 27. We have to get this radical out of the denominator. There's a couple steps to that. Step number 1 is you want to prime factor what's under the radical sign. Primes, you want to factor things into 2, 3, 5, 7, and 13 if there's a 13 there. So for example, 6 is 2 times 3, and this is 3, and this is 3 times 3 times 3. Okay, let's look on the outside. Does the outies, question is, you can reduce those. Can you? You guys, can you? So these don't reduce, so we leave them alone. Now look under the radical sign, and you ask yourself, does anything cancel out of that? The answer is yes. What is it? Guys, you can tell. The 3's cancel, cross them out. Yeah, so now we have 2 root 2 over 3 root 9. Problem is we still have a radical in the basement. The way we get rid of it is we multiply top and bottom by the same radical. So now we have 2 square root, we factor it out. We have 2 square root of 2 times 9 over 3 times 9. You guys okay? Understand? There's a couple more ways we need to reduce. So we're going to prime factor again. And this we're just going to leave at 3 times 9. You ask yourself, do you have any dates under the radical? Yes or no? Okay, we're going to pull them out. You pull out a 3, you cross it out. Now that 3 coming out now cancels with that 3. Final answer, 2 root 2 over 9. Two root 2 over 9. That's your final answer for that problem. Okay. All right, students, let's take a look at number 7 here. Number 7, it says find the missing side. And we see that we have 2 sides and we need a 3rd side. So we're going to be using the Pythagorean theorem. So go ahead and label your legs and your hypo. And let's write our Pythagorean theorem. Remember, I prefer the descriptor version, which is legs squared plus legs squared equals hypo squared. All right, so you write legs squared plus legs squared equals hypo squared. And we're doing that because we have 2 sides and we need a 3rd side. Now we're going to circle plug chug. So we have legs squared plus circle legs squared equals hypo squared. It says right here, leave your answers in simplest radical form. So when you get your radical, whatever it is, you simplify it. If it's perfect, it'll just be a number. If it's not perfect, you're going to end up with a number square root of something. And if it's prime, it just stays under the something. So finish from there. Okay, number 11 states, if, can you box that word if for me? If it's a right triangle. Now we know that this works if something is a right triangle. We know leg squared plus leg squared equals hypo squared only works for right triangles. So what you want to do is take the 3 sides, put the longest side by the hypo, and then if this works, it's a right triangle. If it doesn't work, it's not a right triangle. So let's do this. We're going to take one side, so root 7 squared plus another side. And we're going to do equal sign, but put a question mark there because we really don't know if it's equal. We're just kind of testing it. But put an equal sign there because that's what you're used to. Root 9 is obviously the longest, so we're going to put root 9 over here. And we're going to square it. Okay, now we do our math. Root 7, this is root 7 times root 7. Remember, expand your exponents. 1 squared is just 1. This is going to be root 9 times root 9. Ready? You finish the math there, and if it works, if that question mark is true, you say, yes, it is. If it works, it's yes, it works. If it doesn't work, then your answer is going to be no, it's not a right triangle. Okay, students, 13 and 14 are a little tricky. I give you something slightly easier actually on the quiz, but it says find that area, box the word area of the triangle. Round your intermediate values to the nearest tenth. Use rounded values to the next value. Round your final answer to the nearest tenth. So there's several things going on here. First off, the area of a triangle is going to be the length of the base times the height over 2. Well, the length of the base times the height over 2. That's how you find the area of a triangle. We're going to do 13 together. So in 13, let's write that equation out for area of a triangle. Area equals the length of the base times the height over 2. So visually, that looks like this. Your base is going to be this length right here. That's your base. And your height, you already have, it's 5. So for our equation, we have area equals, we don't have the base yet, but we do have the height. Now to get the base, if you look really carefully, it's made up of 2 pieces. We have this green piece on this side and this pink piece on the right side. We do have 2 right triangles. And anytime you have 2 right triangles, we can use the Pythagorean theorem. So for the green piece, that's a leg. So we're going to do leg squared plus our other leg, which is already 5 squared, equals 9 squared. Let's do our math here. That's going to be leg squared plus 25 equals 81. We end up with leg squared and 81 minus 25. Is 46. And for this, now we square root both sides, and at this point you may use a calculator. That's why it's round to the nearest tenth. So we get our calculators, and we're going to do the square root of 46. Wonderful. All right, students, so we're going to round to the 10, so that's going to be 6.8 here. 6.8. So this leg right here is 6.8. Is that what you got? Yeah, 6.8. Okay, now the other one is going to be like this, the pink. That's going to be leg squared plus 5 squared again equals now 64. So we have leg squared plus 25 equals 64. Keep working. Leg squared equals, we subtract the 64 and the 25. That's 39. And then we square root both sides. At this point, you can get your calculator. We round to the nearest tenth. That's 6.2. Now to get our base, we're simply going to add 6.8 plus 6.2. And you should get 13. All right, so that means our base is 13. Now we plug it here, 13. And to find the area, we simply do base, which is 13, times the height, times 5, divided by 2, 32.5. So our final answer is 32.5. We're just going to write units squared because we weren't told what the units were. Okay, so for 15, we first have to write, this is a 45, 45, 90. We see that? So let's write our chart. Okay, there's leg, hypo. Write your chart out. And remember, the chant went something like this. 45, 45, 90, leg equals leg. And then we have leg times root 2. 45, 45, 90, leg root 2. So it reads like this. This 6 is the hypo. So we have to work backwards. What we have here is we have a leg times root 2 equals the hypo 6. So let me give it like an equation. Something times root 2 equals 6. You fill out that something. Something times root 2 equals 6. And once you get that one, you can also get this one because it's leg equals leg. Let's take a look at number 18. 18 is now a 30, 60, 90. So let's do our 30, 60, 90 chart. So in class we did 30, 60, 90, short leg root 3, short leg times 2. 30, 60, 90, short leg root 3, short leg times 2. So those are your function boxes. So for this one, we first find our short leg, which is across the 30. So this B here is your short leg. Now we do our two function boxes. Short leg to hypo, it's going to be times by 2. Oops, let me keep my color straight here. It's red. And the other one is short leg to the long leg is times by root 3. So it reads like this. Something times root 3 is 2 root 3. Something times root 3 is 2 root 3. You find the something. Hopefully you saw this. The answer was just 2 here. 2 times root 3 is 2 root 3. And then you go this way, you times by 2 to get A, which is your hypotenuse. Okay, the last one we're doing here is number 19. The rest you do on your own. So taking a look at 19 here, get it nice and big. Now you should see that you have both a 30, 60, 90 and a 45, 45, 90. So you need to write both charts out. I want you to rewrite it every time. So here, that's 30, 60, 90. Rewrite the 30, 60, 90 chart there. This is 45, 45, 90. Rewrite the 45, 45, 90 chart there. This is the 45, 45, 90, 30, 60, 90. You must memorize these. Let me do the chants we did in class. For the left one, it's 45, 45, 90, leg, 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 root 2. 45, 45, 90, leg, 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 root 2. 30, 60, 90 goes like this. 30, 60, 90, short leg, root 3, short leg times 2. Short leg, root 3, short leg times 2. You need to, some of you need to chant that to yourself about 10 minutes each, and then you'll get it down. Okay, take a look here. Let's look at what we have here. This 10 is a leg. So remember, the legs are equal. That's what's being said here. The legs are equal. So if this is 10, that's 10 down there. Notice it says find all side lengths. You're not just getting the X there. Now to go this way, you're going to times by root 2. God bless Charlotte. So we're going to get here 10 times root 2. That's just 10 root 2. Ten times root 2 is 10 root 2. Outies and E's don't talk to each other. 10's an outie, 2's an innie. Lefty, 3 is left next to each other. Oh no. That's a wonderful neighborhood. Oh. Okay, now this I'm going to pull out. This is a 30, 60, 90. It's getting a little busy here, so I'm going to pull it out. Now that's 10 root 2. That's now the hypo. So our short leg is going to be right here. Blue, that's our short leg. Now do your function boxes. Short leg times here is times by 2. And going short leg going this way is times by root 3. So it reads like this. Something times 2 is 10 root 2. Something times 2 is 10 root 2. Yeah, something times 2 is 10 root 2. Now, if you can't figure that out in your head, you actually just divide by 2 here. And you see that our something is going to be 5 root 2. Now going this way, you do 5 root 2 times root 3. That gets you your long leg. And you're done. Finish that on your own. You know what I say?